Okay, we are now recording. Okay, so
No pressure.
yeah, no pressure. Here we go. Okay, so today we're going to be going over solving rational equations. And what a rational equation is an equation in which one or more of the terms is a fractional one, just like we've been going over. You know, we've had multiple fractions in one grouping. So that's what a rational equation is. And we're going to use two methods to solve rational equations. What we're going to do is we learned how to add, subtract, multiply, and divide these rational expressions or complex fractions. And so what we're going to do now is use those things we learned to solve for like an unknown x. So let's go to method one. If it works. Okay, let's just try. Yes. Okay, so method one. When two fractional terms are equal to each other, what we do is we cross multiply. And so you guys remember when we cross multiplied using ratios before? We're going to do the same thing here, except do it with numbers and binomials, all right? And you use cross multiplication when you just have two fractions equal to one another, right? So we only have two terms. So we're going to put our equal sign, we're going to do 4, and the x minus 2, and now we're in our packet. So we have the 4 and the x minus 2. We have the 9x, right? And whenever we want to get rid of parentheses, what do we do, Tom?
We times both of them by the number outside.
Yeah, we distribute, right?
Yeah.
So we have that equal to 4x minus 8 and 9x. And so now what we're going to want to do is we're going to solve for the x. All right, so how would we do that, Zoe? So subtract 4x, and just to be neater, I'm just going to bring this all up here. So now 9x minus 4x is 5x, and that's equal to what? Negative 8. So how do we get the 5 by itself now? Molly?
Do you want to get 5 by itself?
I mean the x, I'm sorry.
Divide 5 on both sides.
Yes, divide 5 on both sides. We have this x equals to negative 8 fifths. So did everyone follow along with that? Right? Okay. Does anyone have any questions? All right, and so now what we're going to do is check it. All right, so we have x, and what you do, so we have x equals to negative 8 fifths. I'm just going to erase this real quick. So what we're going to do is plug in the negative 8 fifths. 4 over negative 8 fifths equals 9 over negative 8 fifths minus 2. Too big. All right. So, Mrs. Ben, do you know if this would work out?
I bet it will.
Will it?
It definitely doesn't get rejected.
It definitely doesn't get rejected, right?
X can be a number.
Yes, that's right. Okay, so the question is, yeah, right. So also, what we want to do too is check where x is undefined. Right, we want to do that again. So we have, where is x undefined here? 0, and where else? 2. Okay, good job. So we see that our answer, negative 8 fifths, is not a 0 and it's not a 2. So therefore, we know it's a good solution. Do you see that? All right. So now let's go on to the next one. Right, so, okay, method 2. If the equation is made up of 3 or more terms, and if you look on your packet, you can see where this is being explained. There's an equation just like that. What we're going to do is we're going to identify the LCD, but even before that, what I would say is check where it's undefined, if you can. All right? Then we're going to identify the LCD. And then we're going to do what we learned with adding and subtracting. We're going to multiply each side of the equation by that LCD, simplify, and solve. So what we have is, okay, so we're going to do 6 divided by 3x plus 5/4 equal 3 over x. I'm going to erase that. All right, so first thing we want to do is see where this is going to be undefined. So what can x not equal? 0, right? And that's it. Doesn't seem like it can, everything else seems like it'll work. So what we're going to do now is find the LCD. So we're going to circle each denominator. and see what the LCD is. So what do you have as the LCD between 3x, 4, and x? 12x. Does everyone see why it's 12x or no? Everyone's got that? Alright, so what we're going to do now is we're going to multiply both sides of the equation by 12x. And once again, you know how remember when we did the numerator and the denominator, I just distributed it to each fraction? I'm going to do the same thing now. So we have 12x. We're going to have 5 times 12x and 3 times 12x. And the reason we do this is because we don't want these denominators. We want to cancel them out or reduce them, and so this will help with that. So, is it Erin? Erin, how do you do the first term? 12x times 6 over 3x.
So you're going to reduce 12x and 3x by making it just 4x.
4x in the numerator, right? I mean, that's going to be 4 times 6. Now for the second one, what are we going to do, Paige? And this is 12x times 5 over 4.
So the 12 is 4 reduced.
Mm-hmm. And that goes to 3x times 5. And the x's go out of here. So what we're going to have now is all of our denominators are gone. That's why we do this. We can get rid of the denominators. So what we have now is 4 times 6, which is 24, plus 5 times 3x, 15x. Actually, I don't need that. That's why we're doing this. Okay. Equals to 3 times 12, which is 36. And now what we want to do is we want to isolate the x just like we would in a regular equation. Right? So what are we going to do? Phil?
Subtract 24 from both sides.
Subtract 24 from both sides. And we're left with 15x is equal to 12. Right? So now we're there. So now we have 15x is equal to 12. And what are we going to do? Anyone who knows? Probably all of you know. Will?
Divide by 15.
Divide by 15, yeah. Okay, x equals 12 15ths. And now you always want to check, does this match up with any of the numbers that will make this undefined? Yes.
Wait, should you reduce it or no?
You can, yeah, you can reduce it. And so what would that reduce to?
From 8 or...
Yeah, it reduced to 4/5, right? Divide by 3 on each, and you get 4/5. So x equals 4/5.
Should you put it in decimal form or just be like...
Keep it as a fraction. You want them to keep it as fractions, right, Mrs. Sinclair? Not in decimal form. Okay, so let's go on to the next one. Did I want to
Check your domain. Always check.
Yeah, always check your domain. That's the right way to say it. Check your domain. And the domain is where you're checking where it's undefined.
So if they plug the number in, you can use a calculator. to make
Yeah.
sure it works.
Okay. Yeah, if you're on the region or something, you can always double check with your calculator just to make sure you got the right answer. Alright, so go to the next one. Okay, so it's extremely important to check. Not every answer that you get will make the original equation true. Alright, so first what we want to do, find our domain, or where x is undefined. So where is x undefined? Make it undefined. Dana? At -1, and what else? 1. Good job. Everyone see why that's true? Alright, so now what we're going to do is okay, so we have these two, right? A plus 1 and a minus 1. Now a squared minus 1, we want to simplify it, or we want to factor it, so I can see if there's anything in there that's in the denominator that we could add to this nice list as well. So, Jess, G. What does this factor out to?
A plus 1, A minus 1.
Yep. Alright, and since that's the same as these, we're not going to get any new areas for undefined, or any new numbers. Alright, so now what we're going to do is look for the LCD. So what's our LCD for this?
A plus 1, A minus 1.
A plus 1, A minus 1. Alright, and so what we're going to do is we're going to multiply each of these terms in the numerator by that. So we'll start here. A plus 1 times A minus 1. It's going to get a little crammed, but A plus 1, A minus 1, and A plus 1 times A minus 1. Everyone see what we're doing? Alright. So Emma, what can we cancel out in the first term? What can we reduce?
A plus ones.
The a plus 1s. So I'll do this down here. And so what we're left with is a 1 times a minus 1. Right? Oh yeah, and so our LCD, yeah, it's going to cancel that stuff out. Okay, now plus, what cancels out in the second term, Ryan? Right here.
A minus 1.
A minus 1. So we're left with 1 times a plus 1. And that is all equal to what? To 2, right? Yeah, because those just cancel out or reduce. Alright, so how do we get rid of parentheses? Distribute. So we have a minus 1 plus, distributing the 1, a plus 1, right, equals to 2. Negative 1 and positive 1, those go to 0, and so we're left with 2a equals 2, right? And so a, divide 2 on both sides, and you're left with a equals 1. Now, does this match something that makes it undefined in the domain?
Yeah.
Yes, so what would this answer be? It would be undefined. Or another answer would be does not exist, right? So that would actually be the answer, does not exist. You see that? Any questions? Or are you picking up? You guys got it? Okay. What do we have next? Okay. More examples. Alright, so who thinks they know how to do this one? Dana, what do you got to do? Cross multiply, right? So we have 3 times x minus 3 and 2 times x plus 1. We distribute 2x plus 2 is equal to 3x minus 9. We're going to isolate the x's, just like we learned to do. So isolate the x's. We'll subtract 2x from this side. And we're left with 2 equals x minus 9. Add 9 to both sides. And what we're left with is x equals 11. Now what I actually didn't do this time was find the domain, which is wrong. You should always, even if you get to this point, that's fine, but just go back to the original fraction and see, okay, well where is this undefined? So where is this undefined? Anyone? Negative 1 and 3, exactly. And does that match our answer or no?
No.
No, so this is our answer, right?
Yeah.
All right. Let's see. What is next? Oh, okay. This is a good one. All right. Lucas, can you help me with this one?
Yeah.
All right. So what would we do first?
Find a common denominator.
Find a common denominator. And what would that be?
2a times a plus 1.
2a times a plus 1. Does everyone know why Lucas said that? Yes? Anyone? Does anyone not? I feel like that's a better question. You do have to find the domain first, or it's a good idea too. Oh, Lucas. No, it's okay.
0.
You're good. So what would the domain be though?
0
0.
and negative 1.
0, negative 1, right? Okay, good job. Right, so now that we have that, so now we're going to multiply what?
2a times a plus 1 times to the numerators.
Mm-hmm. Exactly. So we're going to do that to all the numerators. And then we're going to reduce and see what we have left. So who wants to reduce this? Chelsea, do you really want to reduce this? Would you mind reducing this? You don't even have to reduce this if you don't want. Okay, so what did you get here? The first term right there. Mm-hmm. Yeah. Times, or the minus sign is on the right, so yeah, it'd be a plus 1 like that. And then we'd So again, now we're going to see what reduces here. It's 5, 2a times a plus 1 over 2a. 2a's, right? And what are we left with? And on the right side of the equation? Exactly, and we're left with? Yep. All right. So now what we're going to do is, once again, whenever you're doing this, you want to combine like terms, but in order to do that first, what do you have to do, Paul? You have to distribute, right? Okay, so we're going to distribute. So this is going to become a 4a. So we're going to distribute the 4a to the a and the 1. Get 4a squared plus 4. And now, what does this turn into? Minus 5a. Is it really?
Oh yeah, it's just a.
Oh, you're right. Okay, thank you. All right.
No, for the first thing.
4a squared plus 4a. Okay. Here we go. Okay, so then we go minus 5a minus 5. Right? Is something wrong? Oh, okay. I thought someone said something. I mean, maybe someone did. But, okay. So then 4a squared. And this is kind of how these problems go. So you're going to find the common denominator, distribute that to each of the numerators, simplify, and solve. And you guys know how to do this pretty well, I would think. So now we're just going to combine like terms. So what will we do? Who is it? Kyle. How do you combine the like terms to solve for a?
Negative a.
So that turned into a negative a. Yeah, that's right, because those we both get out of there. And now what we're left with is negative a minus 5 equals 0.
You add the 5
Yes, you add the a. Yeah, add the a. It might be easier just because then you don't have to divide by a negative number. Not that that's a big deal. Yeah, and then our answer is a equals negative 5. And is that something that is in our bad list? No, it's in our domain, right? Yeah, the technical word is domain. Okay, so a is equal to negative 5. All right, so it seems like you guys got this. All right, what else do we got? Is there any ones you've been like itching to do that you saw? No? Really? Oh man, I see tons of them. All right. How about, how much time do you have left, Mrs. Sinclair? 5 minutes? All right. And did they have homework today or no? Okay, you don't have homework this weekend, so just to not disappoint you guys, we're just going to do number 4. Okay? Yeah, you know what? We did something just like 3, so you guys would be able to do it. No problem. I understand, if there is a problem, this is a great period, because once you're done with this class, you could just stay for 10th and do more math. I mean, that's what I do every day, and I love it. So, even though I'm tired sometimes. Okay, so let's solve this. Okay, so first, what is our undefined list, our domain? No, stop. Okay. Okay, so x does not equal 8 or 2. That's right. Okay, so now we're gonna, so we know that those are good. Now we have to factor this to see if there's anything else that x cannot equal. So what does that factor to? Let me pick someone, Sarah. I never call on Sarah, Sarah.
So x minus 8 times x minus 2. Oh, that. X
minus 8, no, that was right. X minus 8 times x minus 2. Good job. All right, and so now we see that x minus 8 and x minus 2 are the same as these two denominators, so we don't have anything new to add to our list, right? So what's our LCD? LCD, yes. X minus 8, X minus 2. All right, so what we're going to do now is multiply the numerators of each of those by that. And how about you guys do this and see, first person to get it, just call it out, and we'll see if we get the same answers. I mean, you might beat me too. I'm not the fastest writer. So. What is 6 times 8? That's what I got. Thank you.
X equals 12.
You got it?
Yeah.
Lucas.
Oh my goodness. Oh, Lucas and Paul.
You said call it out. I don't know.
Oh, I raised my hand.
I mean, that was, you know what? After yesterday's homework, after yesterday's homework, following instructions is very important.
You said call it out.
No, it's not.
I'm just kidding, guys. I'm just kidding. Oh, no, did you call it out?
Yeah.
Okay, then Lucas gets it. No, what did you get, Lucas?
X equals 12.
X equals 12?
Yes.
Okay, now I'm going to check the key. He's right? All right, guys. Emma, what did you get?
X equals 12.
Okay, I'm going to trust you guys. Oh, Ryan says X equals 12. Okay. All right, guys, so that's lesson. So if there's any questions or even anything we went over yesterday or the past couple days, you can stay for 10. But if you don't on a Friday, I also understand.
Lucas followed along.
So embarrassing. Thank you. I know.
Thank you, Shreya.
Emma and Lucas beat me in math. And a lot of you guys. Sad day for Mr. K. Yeah, it's true. You know what? Sure. Should be like a sage or that's very wise, Kyle.
It was simple.
You don't need